Hi, I'm Pierre Morales, and welcome back to this series of videos where together we learn how to code in Solidity. Today we're back working on our blind auction that we've already had 2 episodes about. This one is the third and last concerning this auction. What we've done so far actually is create just a function that allows it to actually place the bids and record the highest bid and the highest bidder. We've created a function that allows whoever lost a bid to another higher bid to withdraw whatever was added to our pending returns mapping. We declared a function to just call the end of the auction and also a function that allows users to bid using as argument a hash that is created inside of this function using this key KECCAK256 and the encode pact function. Now today, what we're going to be working on is working on our reveal function. And this one is the one that is actually going to control, that will be called basically only after the bidding period is done. And this is what will allow users to actually reveal their bids, place the bids, calling the place bid function, and show to everyone who is the highest bid, who is the highest bidder, and who won this essentially. This will also be available only for a certain amount of time, and then we'll be able to call the auction end function, and just pay everyone that is needed, and we'll be able to withdraw. So let's go. So what do we need? So the reveal function actually takes 2 arguments. What the users are going to pass is first uint, but it will be an array of uints. That's how we declare it. That we're going to keep in memory, and we're going to call values. So this is what the user will input as the values that he has actually bid. Then another array, there will be an array of booleans that we're also going to keep in memory, and this one we're going to call fake. So simply the list of right here, 2 lists. The first will be the list of values, and then the list of whether these values and these bids are true or not true. Awesome. That's it. Just these 2 arguments. So we're going to go like this. Here we go. Now, the next thing that we want to do is we're going to declare this function public. It has to be accessible from outside of the contract. And then we're going to call our modifiers here. So the first one is going to be only after the end of the bidding time. So only after bidding end can we call this function, and also only before the reveal end. So reveal end is an argument from our constructor that we have here, and it simply sums up whatever time we pass as argument to the bidding end. So it'll be we'll see when we declare it, but basically it can only happen after this time, so the time we authorize for each user to reveal their bids. Okay, cool. Now, after that, we actually start our function. And the first thing we do is we declare a new variable that will be called length. And in this length, basically, we're going to get the length of the array of the bids for the user. This is going to be basically the count of bids that this user has done. So length, and we're going to say, so bids message.sender. So using the user's address, we're going to get the array of bids that he has from our bids mapping. And we're going to get just the length of this value. And what we want to make sure is that whatever arrays he's passing to us here, their length is equal to the amount of bids that he has. He cannot pass more or less. He should pass really the amount of bits that he has. So we're just going to make sure that values.length is the same as length. And we're going to do the same thing for fake.length, making sure that it's the same as length. Awesome. Okay, so now that we've got this, the first thing that we're going to do is we're going to declare a new variable that will be just used inside of this function, and we're going to call it refund. This variable is the one that is going to stock the amount that has to be refunded based on the bids that were not actually placed because they were too small compared to the highest bid. So we're just going to stock this value in here. And what we're going to do now is we're going to actually iterate, so loop, using a for loop, through all of the bids that the user did, right? So we know how many he did because we got this length value here. We're just going to loop through that from 0, the first index, to the last one. So in order to do this, we're going to do a for loop, and we're going to say for uint, we declare our iterator I as a uint equals 0. And then we're going to go to, so I has to be smaller than our length. So this is the maximum amount. We're going to go one by one. So we say I++. So inside of this, what we're going to do is we're going to declare also a new variable that will be of type bid. We're going to keep it in storage, and we're going to call it bid to check. And we're going to set it equal to the list of bids for message.sender, so using his address. And actually, the bid that we're looking at is the bid that is at index I, so the current bid we're iterating through. So once we have this, now what we're also going to do is we're going to get values. So we're going to, declare new variables, value and bool fake, that are going to be basically using the same iterator, taking the values from the list that are passed here by the user. So how do we do this? So it's going to be also like this, and we're simply going to say values I, and then fake I, right? So it's going to allow us to get these values using the iterator. Now, once we have these, what we can do, just like our generate blinded bid bytes 32 function up here that takes these, the value and fake as parameters, but we're going to use the same thing, and I'm actually going to copy this here. We're going to use it in order to verify whether or not the bid that we have saved, so the hash we saved for that bid, is the same as if we get this value and the value for whether it's a true or fake bid this way, and get the hash. So to do this, we're simply going to say that if the bid that we're checking on, so bid to check dot, its blinded bid, so the hash value that is saved for him, is different than this, so the hash of the value and fake, well then in that case, we're going to simply continue. Continue for Solidity means that just skip whatever codes comes afterwards, simply move back to the top of the for loop and increment, so go to the next iteration. And if it does go through though, what we wanted to do is we want to simply change the value of refund, and we're going to add the deposit that is saved with this bid that we're currently iterating over. Now what we're going to say is also that if it's not a fake bid, so if it's not true, right? If what the user has input is value false, and that the bid to check and deposit is greater or equal to value that was given by the user. So if it's the same value or bigger, then in that case we're going to place the bid. And so we can place the bid this way, where we just pass. So we have the arguments here. We need an address bidder and the uint value. So what we're going to say, place bid. We're going to use the user's address, and his bid is value. Now, if we take a look at the place bid function here, we see that if it is actually a new higher bid, right, then we're gonna if it isn't, then we're gonna return false. And if it is, and we manage to place the new bid, and you see the highest bid is now equal to value, highest bidder is equal to bidder, we return true. So what we're gonna do is simply, if the result from this is true, so what we need to do is say if this, the result will be true, then in that case, what we're going to do is we're going to subtract the value from the refund, because it is in fact a new bid, so the user cannot claim it as part of his refund. He will only be able to get this back and withdraw it if ever someone bid more than he did. Yeah? Now, at the end of that, of course, what we want to make sure we never forget to do is we're going to reset the value of the current bid to check. We're going to reset the value of the hash to bytes 32, 0. And finally, once we went through all of the bids that the user had bid, then after that, we're simply going to pay to the user. So we're going to declare his address as payable, and we're going to transfer to that user his refund amount. Just like that. Now, full disclosure, this code is taken from the Solidity documentation. I recommend you go check it out. It's in the Learning by Example section of the documentation. And this code, I didn't manage to make it work. If we go now into testing it, it simply won't work. So I recommend that you take a look. Maybe you manage to make it work. If ever you do manage to make it work the way it is in the documentation, then let me know in the comment section. So to be clear, this is basically the exact same code, all of it from Solidity. The only difference is I added this function here in order for us to easily, in a convenient manner, generate our own hash that we can then pass into the bid. So the Solidity code does not have this function here. Yeah, that's pretty much it. They also have an additional value in order to actually, get the bids, and that it has to be passed in the reveal function. That is a secret, that is a hash in and of itself. I thought it's complicated and quite frankly useless for our case here, so I removed it. So we only look at value and fake. The rest is like in the documentation. Check it out. What we can do though is make a couple changes so we can actually go test it out. And these changes are quite simple. First off, we get rid of refund. So I delete this, and the refund here too. Okay. And we're gonna do something slightly different. First off, we're not gonna check whether this is true or not. We're not gonna check whether it's true. What we're gonna do is check that it's false. And if it's false, then now at this level is the moment where we're gonna basically transfer the refund to the user. And we're gonna say payable. So we declare his address as payable, and we're gonna transfer, and what we're gonna be transferring to him is the deposit value from this bid that we're checking, but we're going to add one more thing, which is simply multiply this by 1 ether. Why are we doing this? It's simply because we're going to be working in ether rather than just in way. Everything will be done in ether. It's just maybe a bit more simple, more visual for us. And if you look below, actually, I've added this just here, 1 ether times 1 ether, something we hadn't added together in the previous video. But that's just the 3 parts where we have this. Okay, so now basically what we can do is we can move on to testing. And so to do this, actually, we're going to be first compiling this. Okay, so I compile this. Could work no problem. I'll just bring this up here, because in a second when I move here, we're going to be able to deploy our contract. Now, one thing that I can mention here, you see here, I've already got some values here. I can reset them simply by just quickly moving to a different type of environment and coming back, and now all of a sudden we're back to 100 ether. So that's what we want. So what we're going to do is we're going to use the 3 first addresses. The first one will be the beneficiary, the second will be the first bidder, and the third one, the third bidder. And that's it. We're not going to go for more bids. One more thing to note, in the code, we give the possibility for the user to have more than 1 bids. In our testing, and this is due to the problem that I simply didn't manage to make this code work inside of Remix, we're going to just go with 1 bid to keep it simple. But it'll be enough for us to view how this hash value is stored inside of our bids, and how we can work with that simply. So what are we going to do? First off, we're going to copy, we're going to take this one. This will be our beneficiary address. So I'm going to copy it. And if I extend this here, you see I can just paste this address in here. And we're going to set a new, a bidding time. The bidding time will be 3 minutes, 180 seconds. And then the reveal time will be 2 minutes, 120 seconds. And if I just click on transact, then it's going to start our smart contract. Okay, it's up here. You see I can now go down here. And what do I see? I see a lot of stuff. There's of course all of our variables in here, which is, you know, reveal end, which is the timestamp of when will be the end of the reveal time, bidding end, same thing, and beneficiary. We can just open them up here. You see, beneficiary is this, and the reveal end is this. Okay. Now on top of that, we have our highest bid and highest bidder, which of course are 0. Everything here is in fact 0 for now because we've done no bids yet. Now, what we're going to do is we're going to change address to this second one. This will be our first bidder. And we're going to say that this guy is going to bid 10 ether. And so to do that, well, he needs to place his bid, but this bid function only accepts a hash that we get using this generate blind bid bytes 32 function. So we say that this guy, his value is 10, and he's bidding a true bid, so it's false. It is not fake, therefore false. If I click on this, then you see it generates me this hash. And I can just take this and copy it, place it in here. Now, before clicking on bid, I need to make sure that I do have this value here that is 10 ether. And I click on bid. It's thinking, here we have it. So now if I take this address, you can go, oh, you see already that he's got 10 missing plus the transaction fee. And if I go down here and I check his bids, I put his address and the index, because it is an array right now, which will be 0 because we only have one, so it's the first index. And I click on bids. Well, we have it here. There's the hash that he used plus the deposit that he had here. Now, we change address, take another one, and we're gonna this time put 20. Now, 20 means that we need to change the value here to 20, and it's going to be also a true bid. You can have fun yourself, experiment when you put true or false. Just keep it always to one transaction if this is the code that you're using. So we generate the hash, and you see that we have it here. So I copy this and come here, replace this value here, because we're going to be committing to 20. And I click on bid. All right. And it's through. So now we're still waiting. We have like 40 seconds before we can actually reveal our bids. So in the meantime, new bidders would be able to add their own bids. Now, keep in mind that all of this, you see how we copy the hash and so on, it's because in this course, we're only learning Solidity. If you were to do this in a real application, then all of this would be handled by your front end, back end, you know, depending how you organize it, obviously. But the user wouldn't have to do this all himself, right? You would have this automated for him. Okay, so we're about to reach the end of the bidding time. So what users will start doing from right now is they're going to be actually revealing their bids. So now is the open time. We have 2 minutes to reveal our bids. So we're going to select this first user that bid 10, and he's going to come and reveal his bid. To do so, well, he needs to input the values of his bids. In this case, we only have one bid. It has to be an array, and it's one bid of value 10. And it was a true bid, therefore we mark false. And with this user can simply click on transact. So what it does is it takes these two values, creates a hash, makes sure that it's the same hash as the one that we have here, actually. If it is the same one, which in our case it is, then it's going to place the bid. How do we know that? Well, we know that now the highest bidder, it's him. And he has the highest bid of 10. So now the second user comes here, and we select his address. And we know that his bid was for 20. So if I change this to 20, and I click on transact, it goes through. Perfect. And now actually, the highest bid is 20, and the highest bidder has been changed to this address. So what does it mean for our other address? If I come back and select it, what it means for him is if I copy his address and I come here and check pending returns, he no longer is, if we check what happens here in place bid, if it was outbid, it's this part here, he no longer is the highest bidder. Therefore, his bid value was added and mapped with his address, was added to the pending returns mapping. Which means that now if I check using his address, we see that he has 10 ether that are pending return, and he will be able to withdraw them. And that's pretty much it. In 10 seconds, we'll be able to end the auction, which will, if we check it here, which will basically transfer the bid to the beneficiary, the highest bid to the beneficiary. And so if I click on auction end, we have it, success right here. If we come check out the address of the beneficiary, he's now at 120 Ether because he got the 20 Ether from this guy minus the transactions cost. So if we're with this guy and now I want to withdraw it, I click on withdraw. We know that I'm entitled to 10 because we saw it in here. After clicking withdraw, we see that we got success right here. And if I check the value again, we are at 100 minus transaction cost. So we can see here that these two guys bid. This one won because he bid 20 and it was sent to the beneficiary. This guy got his value returned as he didn't win the bid. And that is it. So to summarize really, what we did at the beginning is just bid using this bid function here that simply appended our bidding values to our bids that we have right here, our bids mapping. Yeah, and so this is holding values of the address plus the deposit. So rather a list of hashes and the deposit amount. And what the user later does is inputs directly the amounts that he had inside of this hash to be able to, for all of his bids, just verify that we're looking at the same hash. If we are, then we can actually place the bid. And depending on whether it was the highest bidder or not, it will take over and replace the highest bidder and so on. Now, again, if you manage to make this work with really the code from Solidity, let me know how in the comment section, and I'll make sure to cover it in an upcoming video. If not, I hope that you anyway learned something in this video, and that's it actually for this video, and I'll talk to you in the next one. In the meantime, just take care.